I'm gonna introduce the cell semantic segmentation with MaskRCNN, and next I will introduce myself. Ich heiße Cao Yunlin und meine Fakultät ist Tanka-Universität Software-Ingenieur und ich bin die erste Jahr in Universität. Meine Lieblingsprogrammiersprache sind Java, Python und C++ und mehr. Und meine Programmierfelder sind IoT und künstliche Intelligenz. Ich kann 4 Sprachen sprechen. Das sind Englisch und Deutsch und Spanisch. Und es gibt meine GitHub Repository. Und in meiner Leistungen, es gibt 3-mal verschiedene Themen in Taipei Wissenschaftswesen und die Noten sind gut und besonders. Und die sind auch in Informatik und Anwendungsgruppe. Und ich habe auch Microsoft Office Specialist Certificate und Test-Staff Certificate und Goethe Artsweit Certificate. And the motivation is because the tracking the single mitosis cell costs a lot of time. So we choose use the cell segmentation to operate it automatically. And the algorithm we choose is MaskRCNN, Mask Region Convolutional Neural Network, to make the analysis more efficiently. And the reason we choose the MaskRCNN because it is simple and it can fashion the feature by using masks and of the region of interest for image for the further analysis. And the concept of the RCNN region convolutional neural network is it has the most important algorithm, RCNN, and RCNN is using the input data to use a square matrix scan over the input data, which is the image, and get the features like the blue dot and get the hidden layer. And then the training process is the machine will get the input data and the output data, and it will find the hidden layers and predict the predict data. And the predict data and the output data will have some bias. We will optimize the bias by backpropagations. And the working environment we choose today is Python 3.8 or later. And the reason we choose Python because it has a greater package called TensorFlow for using the machine learning algorithm like neural network and so on. And the environment of the Python is using Anaconda 3. And what's more is the PMZ is the package which is the ImageJ commands in Python, because the ImageJ is based on the Java programming languages. And the features of our programs can be converted the ImageJ ROI into couple training weights, and training with various arguments like confidence rate, epoch, and steps. And we can get the weight file and testing it by detecting the images, and it can export it by 3 types of the export data, like image RI, user-friendly implementations, and the black and white mask images. And all of the both can use in the batch processing. And then the Preface, we are using the 2 different datasets to train the model. One is define the regions of interest of single mitosis or non-mitosis events. And the other is the cell segmentation. And the first dataset is using the temporal color-coded images, which is projected into the two-dimensional images and defined in image.ri. The second one, we duplicate the events and into the videos of our eyes. And for the further information, you can go to my GitHub repository segmentation. And the example is result of defined ROIs, single cell events, mitotic events or non-mitotic events. And we can see the user defined only had a free event catched, but using the MaskRCNN, we can catch more. So in this case, MaskRCNN has more advantages. And here are the example results, single mitosis and non-mitotic events. As we can see, most of the picture can catch the RI accurately, but few of them are duplicated and it has an error. And this one is the MaskRCNN results for the single cell segmentations. As we can see, both of them, gold standard and the MaskRCNN has the same shape of the cell. So in this case, it was almost accurate. But we can see in the single mitosis results, after the separation of the cell, it became more non-accurate. By like this one and this one, it can only detect one of them. And let's compare to our program and free another mainstream program like Cellpose, Zero Cost Deep Learning for Mac, and the Cellcon Explorer. And only of my program can detect image RI. But our cell tracking method is not developed yet. So I think we can learn from the Cellcon Explorer, which is from MBO. And the issues of the MaskRCNN is because the accuracy is low, probably due to not enough database samples or the problem of the algorithm. And there are no tracking systems in our program. So I think the first goal to the mission is getting more database from MBO to improve the accuracies of cell segmentation of my system. And the second is to compare the differences of algorithms between my program and the Cellcon Explorer to understand how to improve this segmentation. And as previously mentioned, the third goal is going to get learn the cell tracking method. And the other part is my references. Thanks for watching.